Booleans have been a staple in 3D modeling for decades, and Modo provides several options that allow you to take advantage of these powerful mesh editing operations. They enable you to combine multiple mesh items in a variety of ways. Before using any of the options, it's important to know that Booleans require clean mesh items to function properly. While Modo will perform Boolean operations on sub-D meshes, the resulting topology is rarely ideal for sub-Ds, and I recommend avoiding it. You'll get far better results working with polygonal meshes. If you want to perform Boolean operations on sub-D meshes, I would recommend exploring Modo's Mesh Fusion toolset, which is designed to work with Booleans on sub-Ds. When working with traditional Booleans, your meshes shouldn't have any open edges, meaning they should be watertight or closed volumes. You also want to make sure they don't have any floating verts, 1-point or 2-point polygons, and no element should share the same positions in 3D space, meaning no verts on verts or polys on polys. It's a good idea to run mesh cleanup on any mesh you plan to use with Booleans to try and catch any issues. While mesh cleanup isn't a fix-all, it usually removes the majority of the issues that can keep your mesh items from allowing Booleans to perform their task. It's been my experience that Booleans will work 100% of the time if you feed them clean geometry. The best way to understand Booleans is to see them in action, so let's take a look. To work with Booleans, you'll need an active mesh item and an inactive mesh item. As mentioned in the guide, active mesh items are often referred to as foreground meshes, and inactive meshes are sometimes referred to as background meshes. To give you a better idea of the results from the various Boolean operations, I'm going to change the inactive mesh shading style to wireframe. Using an active item and an inactive item, click on the Boolean button found in the Edit subtab of the Model toolbar. We'll start with the subtract operation since it's the most commonly used Boolean operation. We'll keep the drive mesh set to background, which will use the inactive mesh. Click OK to see the results. As you can see, the inactive mesh is used as a cutter to remove the portion of the active mesh where the two intersect. Modo creates new faces to close the area where the inactive mesh cuts through the active mesh. You can use this operation to cut holes or carve shapes into meshes. The intersect Boolean operation removes all sections of the two mesh items that don't overlap. I like to think of it as the exact opposite of subtract. The remaining two options have been known to cause confusion with many users because on the surface they appear to do the same thing. If we use the union operation, both the active and inactive meshes are combined and any overlapping geometry is removed. If I use the keyboard shortcut F to flip the polygon surface normal, we can see the combined mesh is hollow inside. If we run the Boolean add operation, the results appear to be the same on the surface. But using the flip command again, we can see that all of the overlapping geometry still remains. This is something to keep in mind when using the add operation. In most cases, you'll want to use union instead of add. But since every project is different, it's good to know that we have all 4 Boolean operations to choose from. Solid drill is an additional set of Boolean operations that use the same setup as Boolean operations but produce different results. The core operation removes all geometry except where the two meshes intersect. Unlike the Boolean intersect operation, Modo doesn't create any new geometry. Tunnel works similar to the Boolean subtract operation, but like core, doesn't create any new geometry. The slice operation is a great way to use existing geometry as a cutting tool to cut new edges into the active mesh based on the intersection of the inactive mesh. When using drill to slice into a mesh, I prefer using the stencil operation. This works just like the slice operation with the added benefit of being able to assign an existing material to the overlapping polygons of the active mesh. The axis drill operations are similar to the solid drill operations except they use a 2D mesh projected down a user-defined axis. It's important to take note of the correct axis to use. The number one reason users struggle with axis drill is forgetting to select the correct axis, which usually results in either nothing happening or undesirable results. It's also good to know that the drill operations work on 2D active meshes. So unlike Boolean operations, the active mesh can have open edges and doesn't need to be a closed volume. As a side note, when using the freeze curves as faces option and enabling make holes, you're performing an axis drill tunnel operation. So make sure to select the proper axis when using that command. So far, all of the Boolean and drill operations we've performed have been destructive. As we discussed in the guide, any direct modeling operations we perform are destructive, meaning once we commit, they're locked in. If you'd like to work with Booleans and drills in a non-destructive workflow, take advantage of the procedural version of these powerful options. Simply select the mesh you want to work with and add a Boolean operation to the procedural stack. Choose the mesh you want to use as the cutter and click OK. The result will be the same as direct modeling, but the operation remains live so you can edit the meshes at any time. If you find that you use procedural Booleans often, I'd recommend taking a look at the Mop Booleans kit, which is designed to speed up the workflow of working with procedural Booleans. We covered a lot of options in this video, so be sure to spend some time experimenting with all of them so you become more comfortable with these powerful mesh editing commands.